Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast, brought to you by Alti, the Audio and Loudspeaker Technologies International. And of course, people want to find out about some of the other episodes, please check out our website, totalharmonicdiscussion.com, kind of a clever play on THD. And today we have guests coming in, Resonado Labs. They have some interesting transducer technology, some flat core speaker approach, a new approach to building transducers. So without delay, let's say hello to everybody. So Simon, our co-host in Japan, how are you today, Simon?
Not too bad, just coming off the back end of a cold, which is that sort of season, I guess.
Okay, good thing it's not the big cold. Maybe we can't mention that on YouTube. I don't know. It's crazy these days. So with us today, Paul Vedier, Senior Acoustic Simulation Engineer from Resonado Labs. How you doing today, Paul?
Pretty good. How about yourself?
Pretty good. And you're in Chicago? I think I could see.
I am, yes. Yeah, we got Sears Tower over there.
That's there's the landmark. And Peter Moeckel, Chief Operating Officer and co-founder of Resonado. How are you doing today, Peter?
Doing well. Thank you, Dave. Thank you, Simon. Is your background live, Dave, or is it...
So yeah, this is our office in Hong Kong, and we're in a warehouse district. So it's not... That's actually a picture out the window, but we kind of fake it because if we put the camera to the window, then it would be too bright. So anyways... So yeah, this is our office in Hong Kong here on the east side of the island, if anybody's curious. It looks nice, but it's actually a recycling center down there. So it's all kind of garbage. But let's get to the speaker tech. All right, so one of the desires of everybody is to get more sound out of smaller spaces. And there's been a lot of work in this last 30 years, everybody trying to get more out of small spaces. And so you guys have been around for a few years, I think, but can you guys maybe tell us about the origins of the company and where it came from?
Sure. I have a few slides prepared that go over that. I would say what's interesting, Dave, about your statement is that everyone has been trying to squeeze more sound out of the same space, but it's all been based off of the conventional electrodynamic speaker driver, and we haven't really seen a futile attempt off of a different structure, and that's why I think what Resonado is doing is so interesting. So Resonado Labs we design and we license proprietary speaker technology, and the goal is to enable innovative designs. Our first technology is what we call flat core speaker technology, or FCS. To answer your question directly, Brian Cho, who's our CTO, all the way on the left, and then LH, our CTO, originally invented this technology in the 2000s and 2010s, and they were doing initial R&D. We began full-scale operations in mid-2019 when we really saw a lot of market trends going to really pushing towards efficient speakers or high-performance speakers in tight spaces. And that's why we began full-scale operations. I would say in the beginning of 2020, we released FCS technology officially, or the first product, which is the Neomid5. And I have a sample. This sample has a honeycomb diaphragm, and what you see in the screen has a carbon fiber diaphragm, but very similar driver. And we currently are working on the second generation of this driver, but there are a lot of interesting projects around it in the works with our licensees, and we will talk about that on this slide. So we signed our first licensing agreement with Xylix Acoustic in June, and they are doing a lot of business right now in the home audio space. They do a little laptop business, laptop speaker driver business. So we're working on a few soundbar projects with them. We signed a second licensing agreement with SoundLab Technology Co., which also goes by the name of Microlab OEM. And we also are pursuing multimedia projects and automotive projects.
Okay. Yeah, those are two famous OEMs over here with like Will and Wyatt at Xylix, and then Jack Peng over at SoundLab, because they've been in building speakers forever, pretty much.
They're both very good partners, and we are all working hard to integrate FCS technology into the mass market. The last piece of news is from February, is that we signed a partnership with Airstream, which is a premium RV company. You guys are, I believe, familiar with the Silver or Sleek RV. So they'll be releasing some details on the actual vehicles and the FCS sound systems that will be going in shortly. But that has been exciting.
Okay.
I think we could go a little bit deeper into the technology in the industry. I would say, starting off, we all know about the conventional electrodynamic loudspeaker. It's been around for decades and decades, and it's very efficient. It's very good at producing sound, and if I said otherwise, there would be some pushback. But as you were mentioning, Dave, as audio products have become more mass market, especially around 2015, 2016, 2017, we saw the rise of smart speakers. Soundbars just took off in growth. Automotive audio became much more important. Phone audio, laptop audio, all these applications took a bigger or leaned further on audio. And we also saw this just with COVID. I know a lot of these soundbar brands and multimedia brands and smart speaker brands saw sales double the past year. But with that has come a need for speakers with great performance, but that enable these new, sleeker, and more compact designs. My question for you, Dave and Simon, is what is common between all these products regarding the speaker driver specifically?
Magnet, coil and magnet structure.
Yeah, my answer is compact.
Coil and magnet structure, but they do use compact speaker drivers. But what kind of speaker driver?
Maybe neodymium based to get that.
That's probably true, but that's not what I am getting at. What I am getting at is they all use racetrack conventional speaker drivers.
Okay, yeah.
So in the top left, that's a NAM Bentley system. I forget the exact vehicle. In the top right, you see the JBL Charge 4. The bottom left is just a classic Samsung TV speaker. The middle is I believe, HP laptop speaker. And then the middle right, you see the original Facebook portal. Then the bottom, you see the Vizio Elevate, which is actually a very cool new soundbar that was just released. But all these product space is very important. And each of these products has different dimensional constraints, but with the portal, you want to eliminate or lower the depth and eliminate the part below the screen. So that's why they're using high aspect ratio. With the Vizio soundbar at the bottom, you want to limit the height of the soundbar. And we can go on and on about the dimensional importance in some of these products. But as you guys know, with high aspect ratio conventional drivers, they're good on the form factor side, or they enable better designs, but there's significant performance disadvantages with cone breakup, rocking modes, and there's a general thought in the industry that these are very, you would never really use one of these in a hi-fi speaker unless it was extremely engineered and extremely costly.
Okay.
And that's what FCS technology is all about. They're using a planar voice coil and a planar diaphragm. We can apply even force on the entire diaphragm and eliminate those rocking modes in that cone breakup, but enable innovative designs. Our goal and where we are at now is matching the performance of conventional electrodynamic speaker drivers, circular, but in the high aspect ratio and low depth form factor.
Okay, so it's a different structure to the voice coil magnet construction. Okay.
I think Paul can go a little bit further into the exact components.
Yeah, so I'll go into the technical overview of everything now. So basically, right here, we have a breakdown of our Neomid5 driver. And this is going to be the example driver that we use for all of our data and simulation and everything for this presentation, just to make it easy. But basically, the really important thing here is if you look in the middle, you see a planar magnetic motor structure. So what we've done is we've rolled out the axisymmetric structure to make a planar voice coil on a planar collar or bobbin. And then we've stuck a bar magnet on either side of that. with plates on top and bottom. And so you have this winding width on the bottom and the top of the racetrack for the coil. And that's what's going to pass through the magnetic field. And then that is adhered to the diaphragm. And it makes kind of like a T joint, which is really, really nice for pistonic movement. And then on this next slide here, we can just see a quick animation of how that actually functions. And it's a little easier to actually see that T joint between the diaphragm and the bobbin. And we'll take a look at the results of that structure in a little bit. But in addition to just having one motor structure, we can actually use multiple cores. And we can do this in tandem, which is going to increase the width of the driver, thereby creating more surface area, which is great for woofer and subwoofer applications without increasing the depth of your overall structure. So speaking of that T joint, so this is some Klippel analysis data of their scanning vibrometer system. And what we can see here is that we get really, really great support along the entire length of the diaphragm, which allows for really, really good pistonic motion. So in the graphics window in the top half of that screen, you see a mesh of one of our Neomid5 diaphragm and surrounds and the motion that it's going through. And on the bottom, you can see the total acceleration in red superimposed over top of the resulting SPL, which is the black dotted line. And now, obviously, the closer the red and the black lines are to each other, the better the response is going to be. So we can go into that in a little bit more depth on this next slide, where you can see that, if you want to go to this next slide, Peter.
Do you see the next slide, Dave?
Yeah, I do. Pistonic force.
I do. Interesting. I do not. Oh, well, that's fine. I have these slides memorized. So we can see on the left, we have a 5 kilohertz movement of the diaphragm. And so you can see it's very, very pistonic. And on the right, we have it up to 8K. And you can still see that along the entire diaphragm and on the straight parts of the surround, it's very, very pistonic. You get a little bit of degradation on the very edge on that curved part of the surround. But overall, it's very, very pistonic. And then if you go to this next slide, this is where we're looking at the antiphase component of the driver. So basically what's going on here is we're seeing anything that is going to hinder the output of the driver, and that's what you see in red. And so you can see that even at really high frequencies, this is at 10K, we're getting basically none from the diaphragm and minimal amounts of antiphase from the surround. And then on this final slide, you can see that even up to 13.5K, this is now showing the in-phase motion. You can see that along the whole diaphragm, the whole thing is still acting very pistonically. And the great thing about this is compared with, let's say like a conventional racetrack is still going to use a circular motor along this high aspect ratio diaphragm. So you basically get point source excitation where, maybe at low frequencies, you will get some pistonic movement, but very quickly you'll start to see the whole thing bending and you'll get pretty poor cone breakup at low frequencies. So if we go on to this next slide, you can see we did a small simulation in COMSOL regarding a conventional motor structure versus an FCS motor structure. And basically what we did is we used the same motor parameters, so the same coil length, same magnetic gap, and the same magnetic volume, and we were able to get a much higher BL than a traditional motor structure. And the great thing about that is now we can then reduce the amount of magnetic volume that's necessary in FCS to then match the peak BL value of a conventional driver. So we can actually save a little bit of cost on some Neo there.
Okay, so you try to economize the amount of Neo versus the amount of BL that's needed.
Absolutely.
Depends
Yeah.
on the application.
Yeah.
Is there any concern about like rub and buzz in the manufacturing process? Like, it looks, I mean, it's kind of a universal thing for everything to be perfectly symmetrical, even with round speakers with the voice coil and the magnet. Is that a concern where you guys have some special IP around like the jigging and how everything adds together? Is that a puzzle you guys solve?
As far as like the rubbing and buzzing, I wouldn't really say any more than a conventional. I mean, it's always going to be a concern, right?
Mm-hmm.
And I think that simply because it's new technology, it's just, the manufacturers getting used to it. But we haven't really run into any issues with that. I don't know, Peter, if you want to add something to that.
No, I do think we do have some things in the works on centering the voice coil in the gap and preventing that on the IP side, Dave. But that's definitely a classic question, and it is a very important process or assembly step. And you definitely need to be using the correct jigs, and everyone needs to be trained. And it is at least a little more difficult for someone doing it for the first time, as it is slightly different than how you would center, or the assembly process overall, and centering the voice coil and the diaphragm is a little different than a conventional driver. So it needs a little precision in the beginning, but not an issue.
Okay.
Yeah. And I would also add that, we're not using any kind of exotic materials. And so that really helps with this transition into this new form factor. Is yes, they have to maybe relearn how to center something, but the properties of the materials that they're using, they're still used to those. So it's not too steep of a learning curve.
Okay.
So, Paul, just based on the graphs that you showed earlier, so essentially what it is doing is you're getting no cone breakup all the way up to sort of 10 kHz.
Correct. Yes.
And what's the bobbin material?
So we've experimented with a few different types of bobbin materials. This one specifically is, I believe, aluminum was this sample. But we've tried different materials, a couple different thicknesses, stuff like that, just to see what works best. We're always experimenting, because it's new technology. So we have what works, and we have what we can deliver. But obviously, we're always doing R&D to see what will come next.
Yeah. So is it? Can you compare it to a planar driver, like a what are they called? You put the coil wire onto the diaphragm and magnets either side.
Electrostatic.
Electrostatic, or the electromagnetic version of the similar thing, planar magnetic drivers. Is it in any way comparable to those devices?
Not really. It's really more of just a novel type of electrodynamic when it really comes down to it, because you are still working with that coil of wire. It's just wound more similarly to how like a copper wire for like a wireless charger for like a phone would be wound. And then it's still using the same kind of magnets. It's still using the same kind of plates. It's just a different arrangement.
Yep. And so the key point anyway is by applying the force right across the length of these narrow drivers, you essentially eliminate that breakup mode.
Mm-hmm.
This is at 1 kHz. What's happening at the 1 kHz?
Hertz. Peter, if you want to go back to that.
Yeah, right about there.
So right about there is, I believe in that sample was
is there like a bulk wobble of the diaphragm?
Yeah, slight there with the spiders, yes. But we have been able to do some internal R&D with that rocking mode specifically, and we were able to mitigate that.
And then the other plot you showed was right up at I think it's 13.5 kHz, where you started to get inverted phase. That one didn't actually animate for us. I don't know if it's supposed to.
It was not supposed to. Yeah,
okay.
That was more of just a screenshot.
Yeah.
I would say on a couple of the comments you mentioned, it's common, especially since flat is in our name, for people to ask about electrostatic and planar magnetic speakers, but not, as you know, Simon and Dave, none of those technologies have scalability, especially in the mass market with cost efficiency. They're all using very difficult or complicated configurations, and significant precision is needed. FCS is using the exact same components as conventional drivers, just in slightly different geometries, such as bar magnets versus circular magnets, and a planar voice coil versus circular voice coil. So we do not like that comparison, just because it's not really who we view ourselves as competing or playing in the same arena as, if that makes sense.
Yep, definitely. And the difference between this acceleration and SPL output, where does that come from? So the acceleration is the acceleration of the voice coil, the bobbin?
It's the acceleration of the diaphragm, the surround that the laser is picking up as it scans it. Yeah.
Okay, and then acceleration is theoretically proportional to SPL?
Mm-hmm. Yeah, and so then you can see the easiest is at the higher frequencies where they start to break away from each other a little bit. Yeah. That's where you would have some of the acceleration going in the opposite direction, and therefore it starts to take away from the anti-phase components, where they start to rise up a little bit, and that's in the surround, and that just kind of is where you get that separation.
Right. Got it.
We're doing a lot of work on the both the surround and the damper, because as Paul said, the damper or the spider. Yeah. As Paul said, that's the reason for that mode you pointed out, or dip, Simon. But I guess one example is the Neomid5 in the data we are showing you. It uses a dual spider typology on the back. We've since switched to a tri-spider typology, which helps a little bit at a few different points.
Yeah, there's a huge the big key with that, and I think with rocking modes in general, is just matching your compliance between your spider and your surround. And I think that's something that is yet to be solved by any loudspeaker engineer. And with a new form factor and a new design, it adds to that process. But we've certainly made some big strides in it so far, I think.
So, Paul, do you have quite a background in traditional loudspeakers?
In traditional loudspeakers, yes. Joining Resonado was very interesting, and it's been a really fun ride, because I've kind of just been able to jump into something brand new, and any idea is potentially a really good idea, because you just get to play around with it and see what you can make. So yeah, it's been really fun.
So you had that general theme in traditional loudspeakers is to try and make the diaphragm as stiff as possible and as light as possible. But when you're dealing with this system where you have a linear force line, you don't have to conform to that to quite the same extent. Is that fair to say?
It is fair to say. We are able to use a completely flat diaphragm. It looks like a popsicle stick, really. But the interesting thing is it does still have to be fairly stiff, because the bobbin with this T, the T could kind of do this if it's not stiff enough. So we do still definitely have to worry about it, but certainly not as much. It's it's a nice little padding that or safety, I guess, that bobbin adds naturally to the structure.
Mm-hmm. Yeah, and I suppose there's some weaves of composites that could be strong in X, but not necessarily as strong in Y. I can't remember the name of those guys out of Sweden that do the ultra thin composites, but I'm sure you guys might have talked to them already about strong in Y, but not quite as much in X. So, anyways,
there are a lot of interesting materials, especially in Europe, and there's a couple interesting companies in Thailand. And we are doing a number of experiments with the diaphragmic material on that side. Right now, in this sample, it's a 2.3 millimeter thick honeycomb diaphragm. You can't really honeycomb paper sandwich diaphragm. Mm-hmm. You can kind of see it a little bit. We've also done a little bit with carbon fiber, but honeycomb is a little bit more of a cost efficient and still premium option, but a lot lighter than carbon fiber.
Right. Okay.
So just to clarify on one point, the getting or avoiding the breakup modes leads to a flatter frequency response. Is that the key?
Absolutely.
Yeah. And
So, sorry. Go ahead.
Yep. And so, does that also lead to a higher SPL efficiency or efficiency?
Yeah, I mean, I feel like it does. Peter, if you actually want to go, that leads really well into the next set of, right there. So this slide is meant to show acoustic dispersion, but you can see on the right, it's a little tricky to see, but basically we get our SPL on our driver for the Neomid5 is typically reaching about 84 to 86 dB. And that's at 1 watt, 1 meter. So yeah, it is certainly very efficient in terms of the motor structure versus the output SPL.
Yeah, superb. And that, what was the dimension of that?
It has SD of 23 centimeters.
Yeah, equivalent SD of 23, and then it's a 5-inch by 1-inch driver.
5-inch by 1-inch. Interesting. Okay.
Yeah. And so then obviously with that 1-inch, you get really, really nice dispersion across that axis, which is what we're showing here. So you can see up till 6, 7K, you basically have zero drop off on the graph on the right. And then even at 60 degrees off axis at higher frequencies, we're getting maybe a 5, 6 dB drop off. Whereas if you look at a typical conventional driver on the left at 45 degrees off axis, so 15 less, you're already getting roll off at lower frequencies, and you're getting 5 to 6 dB drop off at 45 degrees versus 60 degrees. So one of the things that we really like to say is that we are comparable to conventional drivers in terms of our specs, but we just absolutely blow conventional racetracks right out of the water.
Cool.
Yeah. And then on this next slide, that being said, we are still high aspect ratio. So there isn't really any getting around the fact that over the long axis, we are going to have drop off at earlier frequencies. Granted, we think that there is some benefit to sticking these in, let's say, a tower loudspeaker where you're not going to get interference between drivers in the column array that you're making if you tune it properly. And then obviously that drop off frequency is going to depend on the actual aspect ratio that we use. If we use a smaller aspect ratio, then it's not going to be it's going to be at a higher frequency because obviously wavelength, once it matches diaphragm length, is when it's going to start to drop off.
Yep. Okay. These are generally mounted as a sound bar type of thing, or there's just quite a wide range of applications?
We feel like there's a that is the next that's the next part of the slide. But yeah, I mean, we do feel like there are a lot of applications. Soundbar is definitely one of them, though.
So I just imagine a soundbar, it's that narrow dimension that really counts, because generally people are going to sit kind of on axis in the horizontal dimension, but not necessarily in that vertical axis.
Yep.
All right.
On the application side, I think there's a lot of different projects that we are in various stages of, but I would say our primary focus early on has been multimedia with soundbars. We like to classify FCS technology into 4 sections. The first is single core, which is referring to drivers with only one motor and one set of bar magnets and one voice coil. The second section is dual core, where we have 2 motors and 4 bar magnets and 2 voice coils. The third is bidirectional, which is something we recently announced and still in the development phase, but very interesting. It's a driver that replaces these spiders and dampers conventionally on an FCS structure with a second voice coil. And you get movement in both sides. And the last grouping is what we call Fcs Micro, and this is for smaller drivers such as headphones. On the single core side, the first driver is the Neomid5, which we were discussing briefly before, and this has an F0 of around 110 hertz and pretty flat extension to 15 kilohertz. The applications we are working on this driver for include soundbars, automotive, especially with the RV project, and then a couple of longer term items. We will go a little bit into the designs over the next couple slides, but the designs FCS technology enables is obviously a very large part. Another single core, I guess one thing on the last slide I forgot to mention is that as we mentioned previously, we did release the first version of this driver in the beginning of 2020, and we've been working on the second version now, and Xilex and SoundLab are both working on their versions per se, and obviously it depends on FCS technology. The drivers, the specifications can be altered or optimized or adjusted just like conventional drivers, as if for a certain application you want a little bit of a better low end and you don't care as much about the high end, or you want to increase the SPL a little bit, make the diaphragm a little bigger. It's very adjustable, just like conventional. The second single core driver that we've been working on is the Neo4 3, and this is a 3x1 inch driver, a good amount smaller than the Neomid5. You can see a size comparison right there, but this is ideal for Bluetooth speakers and portable electronics, even smart speakers. Regarding the concepts, on the left, you can see a very thin soundbar with 4 Neomid5s, and this soundbar is about 2 inches tall and 2 inches deep. The whole industry is shifting to more compact and minimalistic devices, and this kind of soundbar can enable a full range audio without sacrificing on size. The second concept is just desktop speakers, where you have one Neomid5 mounted in the vertical positioning, and these 2 desktop speakers would produce a great soundstage per se. The last application is using 2 NF3s, and because of the very wide horizontal dispersion when the driver is in a vertical position, you would get close to 360 degrees of coverage, and we see a lot of Bluetooth speaker and smart speaker companies advertising 360 degree coverage, but we know that sometimes that is not always true what they say. Do you guys have any comments on single core? Or these two?
I just want to ask one more thing. Could you jump back to the slide that shows the magnetic structure compared to a conventional driver? That one there. So actually the magnetic flux is channeled between those yoke plates, and because of that construction, you actually have a like a positive and a negative side to the magnetic system.
So the flux is basically flowing in just a circle, and so you have like these 2 plates, top and bottom, and so we have a coil running across the top and the bottom, and so the current's traveling in the opposite direction at the bottom as well as the top. Whereas the conventional driver, it's sort of like a unipolar, essentially. You only have the one direction. Mm-hmm. That's very interesting. And is that to give you any advantages, let's say, in terms of balancing a nonlinearity? Well, the one thing that I can talk about is we have seen some evidence of lower back EMF because of this, because it's not it's not like ending in a pole piece. It's just kind of continuously going through this magnet structure. So we have seen some evidence of that, which has been pretty exciting.
Yeah. So then you have a support structure, a damper, top and bottom as well?
No, actually. So we just have the dampers on the bottom, and then the suspension structure on the top is the surround. I
see. Got it. Very nice.
We have done, I guess we have, there could be the potential to add if you really wanted a lot of suspension, you could add a damper on the top, I believe. And we've done a little bit of that with the separate driver.
Okay, and speakers built in this fashion, do you still characterize them with like a feel small parameter setup?
Yes, absolutely. Yeah, so you can still run them through a test setup and get your teal small parameters.
Yeah, and people are generally, these are always put into a chamber?
Say that again?
Are they always loaded into an acoustic chamber?
Mm-hmm.
Yeah.
Okay.
Excellent.
Let's go to the dual core.
In dual core, as I mentioned before, is when we use two motors, and which means multiple sets of bar magnets and two voice coils. A driver that's been in the development process for a while, but is almost finalized, at least the initial iteration, is this 8x4-inch Neo woofer, and this is very exciting and interesting to a lot of people, both because of its thickness, about 38 or 39 millimeters, and then its high aspect ratio. It's obviously applications such as in-wall and in-ceiling are very relevant, and as with the traditional woofer, but then it's also the high aspect ratio and low depth make it very interesting for putting in a soundbar or some sort of home audio or consumer electronic device. As you guys know, it would be very hard to fit a 6-inch conventional woofer in a soundbar unless you want to really increase the depth and really increase the height, but the high aspect ratio of FCS's structure let this be integrated pretty easily and actually produce a lot more low end than what is in the marketplace right now.
Okay.
Another driver that's very similar to that 8x4-inch woofer, except larger, is the 12x5-inch subwoofer. And this is a larger variation, and the in-wall and in-ceiling applications are very interesting for this application, along with like an under-the-couch subwoofer.
So there's almost no limit on the length that you can go to?
I would say the only limit is on the magnet length that you want. As you increase one dimension of the magnet and leave the others the same, the magnet companies do not enjoy that as much, as magnets become slightly more fragile. But at this length is not an issue. I think a lot of times people always are asking, how long can the speaker be, or how high can the aspect ratio be? And I guess we theoretically could make a 20-foot speaker, but the magnet companies might not enjoy making those magnets.
Yeah, I'm sure we'll find out eventually. We'll prototype something and realize it just doesn't work once it gets to who knows how long. But so far, we haven't run into that.
Good.
These show a few concepts using the dual core driver. On the left, you see a smart speaker. This is very similar to the Amazon Echo Studio or the now discontinued Google Nest Max or the Apple HomePod. There's that 8x4-inch woofer, which I was holding up before. And by the way, this is about equivalent in diaphragm area to a 6-inch conventional woofer. And then that concept is two Neomid5. So if it's positioned vertically, you would get pretty wide dispersion all around. The middle concept is a floor-standing loudspeaker with the 8x4-inch woofer at the bottom, and then an array of 5 Neomid5s. With rising urbanization per se, we've seen a lot of people looking for more compact floor-standing loudspeakers and an array of Neomid5s. Plus, this woofer would enable the width to be decreased, and obviously the tight vertical directivity but wide horizontal directivity really suits this product well with the FCS drivers.
Okay.
And the last concept is something we are very excited about, and a few companies are as well, just an under-the-couch subwoofer. There's been a few brands who have released systems like this. We saw Vizio do a couple, and we've seen Tufel do a couple, but in all of those applications, there's been performance disadvantages from trying to squeeze a conventional woofer to that thickness and that size. So we are very excited to see this in the market.
Okay. That's a classic problem, is hiding the subwoofer for it's they used to call it the wife factor. I don't know if we're allowed to say that anymore, but like the whole wireless concept came about because nobody liked cables. So I'm sure the subwoofer is just as hated in the fashion design of the living space.
I think it's very
Absolutely.
interesting how the market's evolving. You have some brands that are less reluctant to pursue a product strategy, such as the undercouch subwoofer, because some of their consumers want a big subwoofer to represent powerful low end and a great audio system, but other brands are more adapting to more compact designs.
Okay.
I think it's kind of one of the big reasons I was drawn to, wanting to work at Resonado too, I think, is just like, there are other undercouch subwoofers, like Peter said, but they use like 3-inch drivers and call it a subwoofer. And, all these companies are trying to make these products with these form factors, but they're not doing anything about the drivers. And Resonado, it's like, oh, okay, now you can make these products that you want. And also, here's a driver that'll actually work for it.
Right.
So can I ask a little bit about how you go about developing and doing R&D on these things?
Sure. What do you want to know?
So what's the process? How did you get started with it? Where do you get your materials from? Because this is all non-standard stuff.
I would say, Simon, on things like the diaphragm and the surround, a lot of these companies are already producing the diaphragm and surround for high aspect ratio drivers. And there are some high aspect ratio drivers just like this one, but it's using a dual conventional motor that the typical surround and diaphragm companies are already producing these parts. So switching to our diaphragm and surround is zero difference. With the magnets, a lot of the typical magnet companies for the speaker market also serve the automotive market where bar magnets are needed. So they are already used to the geometry. So we can go to the same magnet companies that serve the automotive market and the speaker market. On the frame side, right now we're using mostly plastic frames in our products, but it does not really change compared to we could use a stamped steel basket, or we could use a plastic frame, and there would be no difference in the supplier. On the damper side, we can go to the same suppliers as traditional speakers, but the geometry is a little bit different in more of a rectangular or square pattern versus a circle inside a circle.
Yeah.
I would say the only.
Yeah. How long ago did it start? Did somebody start developing this, and who was that person?
So Brian, our CEO, and LH, our CTO, originally filed the patents during the 2000s and 2010s. Yeah. They did not act upon the patents per se immediately until they saw the evolving market of the greater need for high aspect ratio drivers and kind of being able to optimize the dimension of the product, like I was talking about in the beginning, maybe 2015, 2016, 2017, 2018. I think in 2013, there were maybe 1 million soundbars sold and produced around the year. And in 2020, we're above 30 million, which is crazy. And soundbars are a big driver of the high aspect ratio drivers. Yeah. We began full-scale operations in 2019. And since then, we've established relationships with a lot of these subcomponent vendors, the typical names that you would know in China or the surrounding Asian countries. And we've maintained good relationships with them. We do some prototyping in our own facilities in terms of driver components and testing other things out. And then we work with our licensees for other tests and R&D. And we also work with certain development factories on that end.
Did you have to build drivers yourself first in order to prove it to potential customers?
Versus building
versus bringing the concept and asking them to build samples.
Right. Yeah. So we have always started the R&D process on our end with certain relationships. There's always the contract manufacturer that you can go to and pay for them to build something, and we've always done initial development in our facilities and on our own, and then brought samples to potential partners with their licensees, for example, or with the development factory, for example, or with the subcomponent vendors. But there's a lot of options and a lot of people who are always willing to help the building process, if that makes sense.
Yeah, it does.
And do you license it? So if somebody had a particular size or something unique they wanted, the business model allows for them to cooperate in a design and then maybe shared IP or something like this?
So I think that's a very good question, and I probably should have clarified on that in the early slides. So we design and license speaker driver technology. That is our tagline. So Xylux Acoustic and SoundLab Technology Co. are our first two licensees, and so they are the ones that are doing the mass manufacturing or slight optimization or alteration. Resonado Labs itself is an R&D company, and we will develop various drivers and then pass those structures and samples and the data to the licensees, who then, if company-wide says we want something very similar to the Neomid5 geometry, but we want it to be more of a woofer driver, Xylux and we will work closely with Xylux and SoundLab to meet those customer requirements and maybe try a new surround or diaphragm material or change the suspension a little bit. So Resonado itself is focused on R&D on drivers and various other driver technologies inside and outside of FCS.
Okay. All right. I think there was some small stuff coming up as well.
Thank you.
That's interesting for everybody.
Yes, so this is the FCS Micro, as I said, is for smaller drivers, and this is our headphone driver, which is a very exciting project we've been working on for some time. And as you guys know, the shape of the ear is rectangular; it is not circular. But with so many more active noise canceling headphones and gaming headphones, headphone companies have started using 40 millimeter and even 50 millimeter headphone drivers. And some of these gaming headphones, you're more so wearing a helmet than a pair of headphones. The cups are so
Absolutely.
big because
Thank
they're
you.
using 50 millimeter plus drivers. And with this FCS Intra 60 driver, is what we call it internally, is 60 millimeters tall by 30 millimeters wide, so it can allow a much more ergonomic headphone cup. And the last technology is bidirectional, which we talked about slightly before, Right, this is the first sample utilizing it, but you can see we've replaced the dampers and spiders on this side with just a second diaphragm, and maybe I can try to, it's hard to show because it is three-dimensional, but we're starting with an 8x3-inch mid-woofer, and a couple concepts are here. One, the first is a desktop/smart speaker that is almost 360 degrees of dispersion. And then the second is an architectural speaker. We are seeing IoT invade everyone's homes, and speakers are already being implemented into lights and other devices. So this is a very interesting concept that a few different companies are interested in, to provide full sound coverage to the kitchen in a very interesting configuration.
Okay.
That is the last driver technology we showed. A lot of those recent drivers, besides the Neomid5, are in development, and certain commercial projects are underway or in development with our licensed manufacturers. But we are there's a lot going on the development side. I don't know if you want to add anything to that, Paul.
Awesome stuff.
And operationally, we have. Do you have people in region for manufacturing support, or it's a little tough this year? But what's the situation? How do you manage what's going on in the world?
COVID has definitely been difficult for everyone. We have an office in Chicago where Paul and I both work out of, and then we have an office in South Korea, in Seoul, where we have a few engineers. So we do not have a facility in China. We are looking at expanding over there, we can provide more direct support to our licensing partners and subcomponent vendors. It's definitely on the organizational roadmap, but right now we do not have that. It's mostly been Zoom and virtual engagements so far.
So a lot of either early mornings or late nights.
I think we prefer late nights more so than early mornings.
Yeah, I used to prefer the late nights when I was younger, but now it creeps up on you. All right. Go ahead.
I was going to say, Dave, do you work the typical Beijing time zone hours, or do you wake up a little bit earlier?
It really varies. Usually up early to talk to US, and then you get a kind of a lull around lunchtime, and then when Europe kicks off, there'll be a flurry, and then again sometimes late night to reconnect with East Coast or even West Coast US, especially if you have to sequence between Europe, US, and Asia. That's the worst, and us in Asia take the hit on that one every time.
That is interesting.
All right, so let's
well, nothing further from me at the moment. This is really interesting, guys. Thank you.
Cool. All right, so let's got the contact information on their website. People go to Resonado.com and take a look at reaching out to Paul and Peter to find out more. So, of course, thanks for coming on today. We really appreciate that. And so, of course, everybody hit the like and subscribe and give us your comments down below. Ask any questions, and we'll make sure that these guys get on to answer the questions for you. So, once again, thanks for joining us today, guys.
Thank you, Dave. Thank you, Simon.